Any questions for us, sir? Okay. So we're just going to talk really briefly about what we can know and what we can't know. And then we're going to launch into essentially what you have to understand, or you can begin to understand why people didn't know right away that we, in fact, we're not the center of the universe. So if you have been, online at all, there's currently a debate about the nature of the flatness of the Earth. Okay, anyone here believe that the Earth is flat? Okay, you can liars, make the line for the point of fun, but there's some people who believe this here. Okay, it's there's reasons for it. We're gonna get into them in a second. So do you trust NASA? We're gonna do this. Notice I changed the numbers, the real numbers now. So you're just gonna put your fist up, and then when I say 1, 2, 3, you're gonna show me the number, and I'll have a look around. Okay, you trust NASA? Either 1, yes, a lot. 2, yes, but they might keep stuff from us. 3, no, but I could be convinced. 4, no, they're part of the government on their own benefits. So on 3, 2, 1. Wow, not a single one. Holy snacks. Okay. So no one fully trusts them. Everyone thinks that they might be keeping stuff from us.
I watched Transformers 3. They got stuff on the dark side of the moon.
Transformers 3. Yeah, the documentary Transformers 3, of course. Classic. So, of course, this is what flat earthers believe. They believe that the government is a secret cabal necessary that's holding us down. This is the reason why you don't have money in your pocket, not because we live in an oligarchy. So, they ask questions like, come on, NASA, make your mind up. What's the color of the Earth? And what does it really look like? And there's sort of a more casual explanation you can make for this type of description. What does it really look like? Why does the color change?
The climate.
Wow. Yeah, we don't believe the climate's changing, so that's not a good one. Wow. Clouds are changing, sure, that's good. But when you look at the blues here, right? That blue of the ocean is changing dramatically.
Camera technology.
Cameras? What's that? Oh, different cameras. Oh shit. Have you ever taken a photo and you've just taken a photo of your face with the same camera multiple times? And the color on your face changes?
Is it?
Yeah, it's lighting, color. You can just the way that's processed. Right, a lot goes into the picture. Colors aren't perfect, and the way we interpret colors is very different. So this is the same art, believe it or not. I don't know what to say. Okay. And of course, you might think about, well, why does this even come about? And a lot of it is anti-Semitism. I just like to point at people. Why does it not go forward? How do you respond to questions like, what color are the oceans? They're blue. The land, depends on whether or not there's greenery there. You can see that in images. The planet does change, right? Why is there no video of the Earth spinning? This is a big one. No, there's only still frames. How do you no videos of it spinning? Why are they so weird? And then the reality is, of course, we do have videos of it spinning. They're all really asking the same question. Do we trust NASA? Right, that was the motivation. We trust NASA. Hopefully this works. Videos never like to work. So this is a video of the Earth from the Messenger spacecraft as it flies away. And of course, your response to that is, well, that's from NASA. It's all simulated, bro. No. We'll see that in fact that people knew that the Earth was flat. It was round. They knew that the Earth was round about 6,000 years ago. Pretty straightforward to measure. And in fact, we can measure it ourselves. Okay. How would you measure it? Anyone know? What?
Well, I know that there was like this thing where flat earthers were like proved themselves wrong, where they had a light and they were like, okay, if this light is like no longer there, that means the earth is round, but
Yeah.
if we can see the light, then the earth is flat.
This is a great YouTube video because where's the fucking chart, yo? Okay, hold on. Here we go. Okay, so this hypothesis they had, it said, well, the earth is flat, right? And they said, well, what I'm gonna do is I'm gonna put a little panel like this, I'm gonna put a hole through it. And then over here, I'm gonna make a panel, okay, and I'm gonna put another hole through it, the same height. Let's say this is 10 feet. Okay. 10 feet. And then I'm gonna put a camera here. I don't know how to make a camera, I'm not a drawer. And then they're gonna put a flashlight right here. And they said, well, if you make that distance really big, right? Then if the earth is flat, then the light just goes all the way through and gets recorded by the camera. But if the earth is curved just slightly, right? Then the place that you have to place the hole is going to be slightly higher or lower. The light gets there. And so they do the YouTube video, same heights. Like, do you have the camera or is the light bulb on? He's got on a walkie-talkie with his friend. Like, yeah, it's on. Like, bro, I don't see it. It's on, it's on. So raise it up. He raises it up. And so sure enough, it goes right through the hole. So they accidentally prove, of course, that the earth is in fact curved. Well, they didn't have lamps 6,000 years ago. What did they do instead? What's that? What a well do.
The sun is directly above the world, like directly shining to the bottom.
Mhm.
And then if you had gone like, let's say, literally Earth's top of the physics better.
Yeah.
You like went down to a different city, like, okay, there's a well here. And like the sun looks at the same time of day, apparently, whatever. Like the sun is like hitting it at an angle, at a different angle.
Yeah, exactly right. So you do with a well, you do with a stick. You take a stick. Okay, imagine this is a curved surface. And I have a stick like that. And the sun is over here. I'm a really good artist. Okay. And so then here the shadow is nothing. But if I just walk a little bit over here, then all of a sudden I get a shadow here. By measuring the size of that shadow as I walk north and south, you can measure here. And they did this, and they're right. So like a lot of decimal places. Right, yeah.
Wasn't it also the same way how they measured time too, where they had like I'm not sure if it were the Aztecs or the Mayans, but they had like a kind of like style for the sundial. That's what's.
But sundials are slightly different.
No, that's
Sundials are measuring the path of the sun in the sky. This is measuring the shape of the earth. Okay. Okay, so this whole point, saying that yes, the earth in fact is not flat, round, and it's spinning, even though we don't perceive it. You like to think that you're like walking around on the earth and not really walking through anything, but in fact I am walking through. Walking through right now. Air. So I'm just inside of a fluid. I'm like a fish at the bottom of the ocean. Bottom of the ocean, the fishes don't know that they're in this giant fluid. That whole fluid is moving with them. We can see that the fluid's moving on the earth because it sloshes up and down and up and down. Top of the atmosphere does this too. We don't notice it at the bottom. We're rotating and we're in the bottom of this giant fluid. Okay. Okay. So is the earth flat? No. What about the moon landing? Land on the moon?
Yeah.
Raise your hand if we landed on the moon. Raise your hand if you have questions about whether or not the moon landed. And if you've never thought about the moon landing in your life. Okay, so we did in fact land on the moon. And one of the greatest pieces of evidence for us landing on the moon is that it would have been harder to fake it than to go. So currently you're very used to computers and camera technology being really good, but at the time they broadcast it to the entire world. The whole world was watching. Okay? And guess what? We don't have a lot of friends at this time. Okay, this is the 60s. Russia's not really our friend. China's not really our friend. Not really our friends now either. And you think if we fake it, and we sent them some tape ahead of time of something that we put in a studio, they weren't gonna be like, no, this shit's fake. Right? You can't even get 200 people in the same room to agree to keep a secret. Right? Your friend tells you a secret, first thing you do, you tell your other friend. You think you're gonna get thousands of people working together to fake the moon landing? Okay. So this is certainly fake. Okay. All of their moon landing conspiracies are not fake. But it gets to this point. We trust NASA, we trust the government. Right? Part of us wants to feel this sense of like, I have this secret knowledge, pass it on to you. Come into my group, we'll be part of this group together, we'll share the secret knowledge that only we know, and everyone else being kept out of it. This is why people like conspiracy theories, because they make you feel part of an in-group. Okay? Unfortunately, they're also used to propagate anti-Semitism and hate against minorities. Something we don't really like. So there are some perfectly fine. This stuff down here, you could ask some real questions about. So this is grounded in reality, and up there is like detached from reality. So if you read some of this stuff down here, the FBI really did spy on Martin Luther King, right? That's for sure. This is real stuff, right? And it's pretty scary. So this truth here is very nuanced and pretty surprising, including stuff that we might talk about, like Operation Paperclip in this class. That's a real conspiracy that actually happened. And then up here, you're starting to leave reality, but it doesn't really hurt anyone. Like the idea that Denver International Airport has like secret tunnels under it. Like that doesn't really hurt anyone. Until you continue and you say, well, those secret tunnels are filled with lizard people. And you go up here, you have like okay, well, what does this stuff actually do? Holocaust denial, reptilian overlords. This drives people a little bonkers, and maybe they bring guns to places where there are people who should not be shot. Right? So it's a pathway. Okay, just recognize that when you hear conspiracy theories. It's important to keep this in mind. And it turns out conspiracy theories, the ideas of these overlords watching us, they're not even that clever. Right? They're not that creative. So if you can imagine a world in which the world is fucked up, one that we currently live in, there are explanations. There are billionaires. But they're not billionaires because they're Jewish. They're billionaires because they're exploiting people all over the world. That's the answer. Taxing them, that's the solution. Deciding that there's a cabal, that's not an answer. Shooting up a synagogue, that's not an answer. Right? Okay. So the idea of what we want to do in this class is we want to think about how we process knowledge. Scientists, for all scientists in this room. What do we do when we're presented with new facts? Can we change our own opinions, even if we hold them very tightly? Right? That is the mark of a good scientist. Because we can only see the world what we've already seen. We don't have access to all the information when we're born. Whether you're like super smart when we're born. We're not. Got to go through the process of learning. Best thing you can do is continually change your opinion. Okay? Well, what can you ask the question about? Everything else. Now we talked about there's some things that are not sciencey, right? Like we said, can't tell you what Lincoln's final thoughts were before he died. So there's some questions that are what we call grounded in science. There are questions that are not grounded in science. And there's some questions that are ill-posed, but could be modified. Right? So maybe we can change the question slightly and see if we can answer it. So you could say something along the lines of, well, I'm really curious to know, where did all of this come from? Right? And I say, well, the planet was formed in this way or that way. And then you say to me, well, who formed it? What would my response be? Who is an ill-posed question? Because I can't test if there's a person or an entity that built it. I don't have that capability. I can tell you how it happened, but I can't tell you if it does it for a reason. that make sense? I can show you the mechanics, but I can't show you if there's a creator. Okay? So it's important that we distinguish some of the questions that we can answer and some that we can't. Now we're going to go through a historical tour of astronomy first, seeing the process of constructing scientific arguments, and then we'll get into like all the planets. And that's the best part, because it's just cool pictures. Okay? Okay, so let's start with talking about how we look at the universe from the Earth. We've all basically done this, hopefully. Nighttime, look up. Anyone not done that? Okay. Sure. And what you see when you look up in the night sky, you see stars rising. Which direction do they rise from?
East.
East, and they set in the west. That's weird. Why is it like night after night? Sometimes I go out and like it's like 4 o'clock. It's like 8 o'clock at night. That's a reasonable time. So it's a reasonable time at night. I go out 8 o'clock, and it's 8 o'clock. I look up in the sky. There's a constellation. Maybe Orion's my favorite. And I go and I look for it, and it's not where it was a week ago. It's like slightly different. And then like a few months later, it's like gone. What's happening there? We're going to ask that question. We're going to ask a very important question. Why did ancient scholars reject the currently accepted model for planetary motion? Because currently, I do not feel like I'm moving. Sorry. I currently do not feel like I'm moving, right? You feel like you're spinning? You feel like you're moving through space? No, weird. And why was the motion of planets, not just ours, but the ones that we see, why was that so tricky to explain? So in fact, before we had ever been to another planet, we knew something was weird about them. But they were doing something weird. Going back and forth. Okay, we're going to show that. Okay. Okay, reading time. You all done the reading, I assume, because you have access to the book. You read the syllabus. You're preparing ahead of time, coming to class, ready to engage with the material, your science. Right? Okay. So question, what is the ecliptic? We're going to vote on this, okay? So is it A, is it 1, a half circle extending from the horizon due north through your zenith to the horizon due south? 2, the path the sun appears to trace around the celestial sphere each year. 3, the path traced by the moon's shadow on Earth during solar eclipse. 4, the sun's daily path from east to west. Stop. When you're ready to vote, it's your this one. Let's vote on 3, 2, 1. Okay. Anyone want to answer this one? You're like confident?
2.
2? Why is it 2?
It's the like if we were the Earth, like if the Earth was the center, it'd be the path that the sun would take around it.
Around the celestial sphere, right?
Yeah.
Okay. So there's the equator, as though. Okay, this will work. And we're going to see this on the slide in 2 seconds. Imagine that you have this object. This will be the Earth. We're going to project the exterior outwards to the big sphere. Can you see this imaginary sphere now? And I'll see it together. If it rotates like this, and this is the equator, you're going to project to the celestial equator. This would be the North Pole. This would be the South Pole. And the ecliptic is the line like this that the sun moves around us. And that's not really what's happening. Okay. Let me show you a better picture, because that's a bad picture. That's just my words. The universe from our perspective, we really need to step into the foot of our ancestors. Okay, maybe when you walk out tonight, it'll still be sunny. Like later today, you'll start to see this. What I'm hoping is that week after week, you'll watch the sky a little bit more. You'll pay a little bit closer attention. Like, oh shit, I do see that. Okay. Okay. So there's that beautiful picture. This is the 2D better version of what I did. Okay? So here's the Earth. Anyway, there's the equator. And that's the equator just projected onto the sphere. And what we're doing is we're imagining all of the stars. We're gonna suck them really close, and they're gonna sit on the sphere around us. Okay? And then this path here is the path that the sun takes when it orbits us. And we call it something special, we call it the eclipse. It's inclined, it's tilted by 23.5 degrees. So it doesn't match up with our equator. And we're going to assume that all stars lie on the same distance, arbitrary distance away. This is a mental model. Okay. We talked about those two. We talked about that. I guess I should put it in myself. Okay. And if you tilt the Earth by 23.5 degrees, okay, that's maybe the picture you're more familiar with, kind of tilted away. Then it looks like, okay, this is the plane in which the sun orbits us, or maybe we orbit the sun. That's up for debate currently. And we look like we're tilted down. Does that make sense? I can just rotate those two pictures. So let's talk about how we can talk about the celestial sphere in the first place. Okay, we need to define some words. So that's me. This is a photo of me earlier when I was a baby. And there's north. What's the other ones? South, west, east. Everyone know those? Okay, make sure. And then we're gonna imagine that the Earth is flat. You just told me it wasn't. Okay, it's imagine, mental model. Okay, so locally, I'm standing here, right? I look to the edge of the table, that's where my horizon is. Anything that's below my horizon, can I see it? No. So when we talk about observing, they always talk as above the horizon. We want to know where it is above the horizon. It's the angle that it makes from the horizon. Okay, that's going to be the altitude. And you're going to use degrees. So that's 0, and that's 9. Good. And then once I have the altitude, 0 to 90, all I have to do is rotate. So let's say I want to find something in the sky. I just have to know north, west, east, south, and the altitude. And I found it. Pretty easy, right? Except for the whole sky's moving while I do that, so whatever. That's fine. Okay, let's look at some other fun words there. The word zenith means the directly overhead part. So if you put a spike through my head and it goes all the way up, that's the zenith. We already talked about the horizon, and there's a fun one here. When you connect the zenith to north-south, you form what's called a meridian. So that's this line. It goes all the way over you. Okay. And so you can point, let's say you're pointing from north, south, that's your meridian. Okay. Lines of meridian go north-south. When you're looking, say, on a sky map, looking up, you see a line this way, a line that way, a line that way, or that's south. I guess I should use it because it says the word south there. Where's oh, it doesn't work. Okay, so imagine your meridian goes this way. The individual lines would be these ones, right? And these would be lines of longitude. Okay. Oh, I already did that. Okay. So now let's talk about motions. So we said that every day we wake up, the sun rises in the east and sets in the west. And would you put money on that? Yeah. Absolutely, right? Okay. Everyone agrees that that's like something is factual. So apparent motion appears when you're looking, so for example, north, stars appear to move counterclockwise. Is that opposite of what I'm saying? Counterclockwise, which way is clockwise? Like this, right? That's clockwise? Counterclockwise? So does that picture make sense? I'm looking north, let's imagine this is north. Which direction is west and which direction is east? I mean, we're here, right? North, east, west. Oh, perfect. It's almost like the sign of purpose. Well, put there for a reason. Okay, so the stars are going to rise in the and set in the and they rotate counterclockwise. What if I'm looking south? Now everyone turn around. I don't want to. Okay, now they rise in the east. They set in the west and they rotate clockwise. Oh, what happened? Okay, good. Okay. Does that make sense though? So it's our perspective that's changing their rotation. They're still moving east to west. Okay. The actual motion, of course, is the fact that we are rotating, spinning fast. And if you stood, for example, here, the North Pole, stars just starting to move. Star above you stays above you. Oh, crazy. Right? Okay. The Earth spins counterclockwise with its axis pointed in a fixed direction towards a star called the Polaris. We'll see that tomorrow at the open house. Come to the open house. That exciting. Okay. And west east New York leads LA. Why does this make sense? Well, if you look at it from above, let's imagine that this is our Earth. You can grab an Earth if you need to. This is going to be your North Pole. Okay. And it's going to rotate in the direction of my right hand. So you're all going to be the sun. Okay, and my hand rotates, you see my fingers first, then my knuckles, then the back of my hand. This part here, if I flatten it out, let's say this is the US. So this is still north. This is what part of the US? The east. This is the west, but New York, yeah. So New York sees the sun before LA does. That's why everyone's already had 3 hours of their day. They're all popped up on the stock market or whatever they do in New York. Does that make sense? Does that intuitively make sense? Okay, you're gonna have to use this information in like 30 seconds. Okay, so we know why the stars rise and set.
Because we rotate.
Because we're rotating. It's the same reason the sun rises and sets. Sun. First negative today. Okay. There's also proof of Earth spinning. So this is a fun thing called Foucault's pendulum. Remember that French people love to keep letters in the word and then not say it. So it's Foucault, and there's no T pronunciation. So Foucault's pendulum is really cool. It's a very large pendulum, not like these. Won't work with these. So in Foucault's pendulum, you let the pendulum go back and forth. And the expectation, of course, is that it should stay going back and forth. And if the Earth were flat and not spinning, it would stay going like this. But since the Earth is spinning, the Earth itself rotates while this is moving. So as this moves, the Earth rotates underneath it. And this moves, and the Earth rotates more. And throughout the course of days, as this thing spins, the plane of rotation of the pendulum going like this. Pretty cool. Have you ever seen one? Okay, a couple of people have seen them. There's lots of demonstrations. You go to like a natural science museum, you can see one of these. We'll talk about the laws of motion. Wait, everyone here is taking 2500, right? Okay. We won't talk about the law of motion. What's Newton's first law of motion?
F equals M.
I heard one of them. F equals ma is the second law. Objects in motions remain in motion unless.
Actually.
Right. by an unbalanced external force. And objects at rest remain at rest. Unless talked about like orbiting, for example, is all about constant forces. We'll talk about that when we see it. You know, something going around, something else has to constantly change. It's constantly changing its direction. Even though the speed might not be increasing, the direction is changing. So it must be undergoing constant acceleration. Okay. Okay. This is the first lecture tutorial. You've just learned how to look in the sky. And you're going to now pair up 2 people to a team. I think I printed it out. I hope I printed it out. Okay. So make a new friend. You both are going to put your name on it. Make a new friend. Don't tell me what we're doing about it. Okay. The other hand, I'm gonna send you on the other side. No, no, you're with, okay. So make a new friend. Don't hang out with somebody you've already. No, I need one of you to go over there. One of you 4. So 2 people to a group, maybe 3, but not that many. Wait, what's happening here? Oh. Some trying to they'll do like okay. And see, I'm gonna be walking around. I'll be walking around. If you have questions, you're more than welcome to answer them. These will not be graded, but you need to put your name on it. So I know that you did it. But what I'm gonna look for here is I'm gonna see like what you're doing well with and what you're not doing well with. And this is gonna give me feedback, help me adjust the lecture. Maybe it shows up on the homework. I don't know. Okay, really not discuss people, but you know, it'll happen.
I think if there were some.
And draw on it however you want. It's yours. But they get it again. It doesn't get green.
All
So then the horizon is like that's right here. What we observe from our location. And they that over here, then we. The horizon would be like
So now it's in on so there's are you seeing? Yeah, and they get set on it's like sometimes like. That's what
far because the bars are yeah.
Feeling like.
Okay, yeah, definitely.
So there's another, once they come in. There's another one. They give them position and that's something, but
then it goes.
Yeah, yeah, it's faster now. It's faster on that. Yeah, really? I know. That has maybe by right. Oh, yeah. It's not ready.
They've been great. Just elaborate on it. And that's stuff. So like either A or B, Denver and.
Yeah.
So. I think you can see still even years. So you're holding above, you're holding around.
That sounds right.
Like setting. Yeah, so you think of it like watching the sun go to the ocean. You're pass here for
Right.
will be.
Yeah, this is always. This is looking slightly above.
That's not right.
Oh, what is it? Oh.
I think you can wait, right?
So they're.
Right. Setting when you disappear. And then this one was never right, because it's always. Well, this one is. Oh, yeah.
One person creates the whole thing and the other person will quite.
Yeah. Oh, sorry. When did we?
It's like here. This above the western on the other side. Yeah.
That is like southeast. Yeah. Oh,
Sure, right. Okay, yeah, so right there. You can
Right.
Make their own scale. Walk around the campus. And like off the location. I mean, so.
It's just like that.
Yeah, let's put that over.
Yeah, it's somewhere like that. It's all right. Yeah. Yeah. For which petitions, that's not be right. Yeah.
Or be like this every. I would say the same thing. Cause Bob said, almost the rest.
Well, it doesn't seem present that like the rest of them activities, like starting.
Yeah.
Then here. Yeah.
I like that.
Right, right, starting.
Stay well. It's already good. Like, there's like some, if you look on the other side,
So.
there's a star down here, you never see.
Agreed, yeah.
Never will.
Still. The same way of the origin of records.
It doesn't.
Like, the east and the-
No, it doesn't. It doesn't write the words.
Statement, kind of like. But it's on the west. Then you go and you can look at. At least the house. Yeah.
That's.
Say like the price is at 100 and then you set it.
And we don't say that. No, I can't read it. Or.
Yeah, okay, that's what we.
So they're both on my work.
Well, no, I don't believe this. Not even for any of them.
Not technically.
Oh, no, no. Success?
Right, that's standing here. In the north.
Yeah.
It wouldn't be. So it's one if it's out.
Yeah.
Okay. So this is directly using this going around. South high. So into it, there out high. West, low.
Oh, we need to get a truck.
You can just run away. It's got a good gig, yeah. Oh, nothing for low. Oh, wait, north, over.
That one and get it right. Get into the science review of the child.
So you
A lot more than.
North Star, the five, one.
Reviews and Yeah.
So this time.
No, yeah, you shouldn't take.
north is it into the sky, it's like in that, it's like in the general, it's like.
No, this is California, so no. Wait, no.
Yeah. This is directly above him, but he can. And that's, it's not that. North views.
There's no visual. Purpose, you can write it down on the
Oh, yeah, I mean, that's fine.
Totally. But
Obviously, it's not a wider.
be like, sun, then.
All these.
Yeah, like this.
Well, I would do
Yeah. You want to stand out.
Yeah.
Because it's rounding, if you go to the other side.
Wow.
Yeah. One. Yeah. West. This is the sun. Yeah. Right.
It's pretty close here. All right. So people feel prepared enough to do that? You can finish it also at the end too, if you didn't get enough time. Okay, so let's use some of the things we just learned about. Any questions before we go on? Okay. And we see all the stars of each bank.
No.
Yeah. Everyone agree? Anyone disagree? Okay. So this is the visibility of the stars. So you're standing here. For some reason in Mongolia, you're looking up. See some stars that go around us, around the pole. And then there are stars down here that you never did see. Okay. And of course, that's the way that we see it from our perspective. And this picture actually tracks perfectly with the picture that we had. We looked at the north, east, west. And if we look at these little arrows, rising in the east, setting in the west. If I look down here, looks like it rises in the east, sets in the west. Okay, so it's all consistent. I haven't lied that much. Okay. All right, let's use it again. Don't shout it out here. So the question is, which direction was the photographer facing? Is it 1 north, 2 east, 3 south, 4 west, or 5 not enough information to tell? When you're ready to vote, put your fist up. I know you're ready. This is the picture in question. Let's vote on 3, 2, 1. Okay, I got some. Oh, I got a little variety here. All right, turn to your nearest neighbor, see if you can convince them of your answer.
No, because-
But they have to have a different answer. They already have your answer, find something new maybe.
I'll look at it's on one side rock, and like it starts there, then it direct up. So like it started to feel like these guys started to rotate it. And start putting it, wow, take it off, you know, now, right? I'll get beautiful lights with this one. I explode quickly. Yeah.
Obviously, in the desert areas, they go and that's when you see them. You're like, big stuff.
Actually, let's try it again. You're not gonna when you're ready to vote.
Kind of. I don't know how to.
Let's vote on 3, 2, 1. Oh, interesting. A lot more people have changed their votes. All right, anyone want to support their argument here?
It's either north or
You say no. You think it's either north or south?
Yeah.
So you're convinced that it's 5, not enough information to tell.
Well, unless there's the line where you're saying it's right and then it stops, which means when you stop, take the picture, like it rose from the right and then it stopped.
Well, I mean, I thought about it like, if we're facing east or west, it would look like a line going like across, right?
Yeah, so if we're facing this way, then the lines go like this,
It
right?
would go like a.
Okay, and if we're facing this way, then they go like that, right?
Yeah.
Okay,
So then,
so I like the idea that it's north or south.
Yeah.
Okay,
so then
is it north, south, or we can't tell?
Or,
You think it's north, why?
yes, because I don't see any snow.
Because I don't see any snow. Okay,
No, wait, it's north, like the North Star, kind of,
ooh, interesting, so you recognize what that is?
yeah. And it just like,
Oh.
because it's the North Star, it doesn't do a lot of movement, it just kind of rotates.
That is in fact the North Star, but I did not expect you to already know that. So another hint here was this thing, which is, this is not Utah. It's in Utah. But this is a red arch in Utah. So both of those clues would work as acceptable answers. If you said I can't tell, that's also okay, as long as you got north south. Okay. All right. What?
What is that rock has to do with us knowing?
Well, where is Utah?
Northern hemisphere.
Yeah.
Northern hemisphere. So can you see the southern pole in the northern hemisphere?
No.
Oh, you can't. All right, let's go back a picture. Let's make sure we understand that, right? If I'm up here in the northern hemisphere, all of the polar stars are hidden, right? And so here, the reason why we knew that there's a Polaris is like right around here, makes little itty bitty circles around our North Pole star. Well, you don't know that yet. You haven't seen it. Can't believe anything until you see it, right? Okay. Okay, what about this one then? How long was the photograph? Is it 1 about 10 minutes, 2 about an hour, 3 about 8 hours, 4 about 24 hours, or 5 not enough information? Wow, it's a long exposure, right? When you're ready, don't say it out loud. You're ready. Vote on 3, 2, 1. Okay. Okay. Anyone want to support the argument?
If that is Polaris, if the full circle would be lit up, it would be 24 hours exposure. But because 1/3 of the supposed circle that would be there is lit up, then it's 8 hours.
Nice, nice. So you look in this circle area, because out here you're kind of F, right? It doesn't help you at all. But in here, you're like, wait a second, that should be a whole circle. Whole
Make it a-
circle is 24 hours. And the fact that you could eyeball a third, you know, okay. I don't know if I could do a third like that, but this is in between those two numbers, so I'm good.
Yeah.
Right? I'm very bad with volumes and fractions. But I can do in between two numbers. Okay. So circumpolar stars are these ones down here. These are the ones that never set at your location. So if I'm looking towards the north in this annotated picture, they're rising in the east, and they're never setting in the west. They just go down and then they come back up and then down. Just chilling. Okay. And if you're at the North Pole, you're just going around you like that. There is no actual star directly above us, otherwise it would just sit there. Cool. Okay. So here's our view. We see some stars. Here's the North Celestial Pole. We cannot see all the stars. We can't see any of them actually. The South Celestial Pole. This is another set of evidence, of course, that the fact is the Earth is curved. Because as we move to different locations, we see different types of stars. What is an example of something that is very common in the Southern Hemisphere and we never get to see?
The Southern Cross.
Southern Cross. And it's another before. Okay, Southern Cross, not surprisingly, is a cross, but it's featured in flags. What's this?
Australia.
Australia, very good. This is the Southern Cross. They put it right there on their flag.
They can see it.
So they could see it, right?
Yeah.
They already knew that it had to be a curved surface because they had different stars. They put it on their flag. Is that only all of Australia is taking it? No, okay. All right, what about this one?
Brazil.
Okay, you know, Brazil. What's different about this one?
Green.
No.
Yellow.
What's that? There's more stars. So where is the Southern Cross?
It's like in the middle.
Yeah.
It's here. Okay, but notice something very interesting. Look at this one versus look at this one.
That little.
Yeah, what happened?
Ooh.
Oh, shit, there's flat. So here, if you look at these four, right? This one is on the wrong side. Okay, who's right, who's wrong?
Because you trust the Australian.
You trust Brazil.
I trust
Okay,
Brazil.
so Brazil's flag was designed as though you were outside looking down on Brazil. So this is actually the South Celestial Sphere, and you're sitting on the other side. So this is the perspective you see when you're standing in Australia, you're looking up. And when they designed Brazil's flag, they were smart, clever enough to imagine what you would look like from above it, potentially from below. Isn't that cool? Okay, here's the next one. That one's boring. The same one. Okay, what's that? I think that's Papua New Guinea, but Scandinavia is in the wrong part of the country. Or wrong part of the world.
Oh. It looked like it's already.
Okay, I'll let you guys go into vexillology tonight, and you can figure out which ones these are. They're very cool. There's only 5. Vexillology is the study of flag. You never done that before?
No,
Really fun.
it's fun.
Okay. Cool, right? Okay.
You have turkey one.
Yeah, you have to find out.
Turkey one.
You're excited. You're gonna figure it out. I forgot it. It's written out of my notebook. I forgot. But it's, you know where, which hemisphere it's in? The southern hemisphere. Okay, good. Yeah, you have it?
Yeah, and so the 5 flags that have the Southern Cross is New Zealand, Australia, Brazil, Samoa, and Papua New Guinea.
This is Samoa.
No,
This is Papua New Guinea. I think this one is. I don't know. I know these two are really boring. They're the same, right?
It's the UK.
Well, this is the British influence of colonization in Australia, and this is New Zealand. And New Zealand's trying to change their flag. Great idea. Australia should change their flag, but anyway, let's continue. Talk about daily motion. So there's the best zodiac symbol, right? Forest stone. And you see, as you look up in the sky, these are all the idea of the zodiac are these constellations that lie in the ecliptic. What was the ecliptic again? Yeah, the path the sun follows. So you have to make this little cognitive leap, which is to imagine the path the sun follows, and then you wait 12 hours, the sun is set, and you look up and you imagine that path is still in the sky. And you see all these constellations are dotted in. Okay? And throughout the year, the sun will move through these constellations. Or they say the sun is in Taurus, that's what they mean. The sun is in Gemini, that's what they mean. And so this is a figure 8 hours later. So you see the left-hand side and the right side, there's the sun. And what's wrong with the picture?
It's not in the same position.
The stars need to have moved, right? And what causes the stars to move?
Well, they just say.
The rotation of the earth. So this is a fake picture. I think.
It's a cartoon. False
Gotta
information.
keep you on your toes. Okay,
I don't like it.
okay. So I think we already did that. So let's. Yeah, let's do it. Okay, so far everything we've talked about is daily motion, rising, setting, and changing positions over a few hours. So we're gonna quickly jump into the beginning of historical astronomy. And then we will use this information to understand that. And then we'll come back to like modern astronomy. Okay? Okay. So let's go. What's that? Okay. So astronomy is the oldest science. The first one, the coolest, the best. I don't have any bias. So astronomy was originally, something that is done by people, modern people all over the world. So we see pictures of people in like Assyria and the Middle East, which is like the cradle of civilization in the early 6000 BC, so on. But the reality is that it was done anywhere that there are people, and we see archaeological evidence for this everywhere. The question is why? What the heck were they doing? Who gives a shit about the stars in the sky? Well, before you had your GPS, before you had your phone, your watch tells you exactly what time it is, you had to know. This is really important. When you plant crops, when you harvest crops, when you pay attention to like changing weather patterns. So if, for example, you know that it snows more in January, maybe it'd be good to know when January was, right? You might not have a January yet, but you have that idea of a January. What does the word moon or what does the word month come from? Moon. And in Spanish? Lunes. Right? What does Monday mean? Moon day. Oh, crazy. What is Saturday?
Saturday.
No, not in Spanish. What does Saturday come from?
Saturn.
Saturday.
That's crazy.
What are the other ones? Sunday.
Mars.
Sunday, well, we know that one. That was easy.
Tuesday is Mars.
Tuesday is Mars because it's
This
Martes, yeah.
Miércoles,
is Mercury.
Mercury.
jueves,
Is Jupiter. Friday.
viernes.
Perfect. I'm learning a tiny bit of Spanish. I'm really bad at it. Okay. So interestingly enough, there's this relationship, of course, between the time that we have that we tend to mark off throughout the year with our nearest companion, which is the moon. And the moon orbits us about 28 days. And a month comes from this basic unit of time. Okay. Now there are variations that occur in a month, and we'll talk about them when we talk about tides. But more than that, nothing really happens, right? The moon is not changing like the way that I feel inside of it. That's a different change. That doesn't have to do with it. That doesn't have to do with the moon either. Okay, I'm not a werewolf. What's this thing? Rocks. Correct. Very good. Stonehenge. What's special about this?
It was an observatory.
They're big. It was an observatory. The only reason why this one's special is because it's big. This is not unique. I'm sorry. You go to the Isle of Great Britain or whatever it's called, England. There are like hundreds of these. They're just smaller. They're just like little rock piles. And someone said it was a clock, kind of like a calendar clock. It tells you when things are happening. Because what you do is you just stand in the middle. Very hard to do. Okay, you stand in the middle, and the rocks are lined up to where stars rise, individual stars, where the sun is rising, where the moon is setting and rising. All of this is happening in these little places. Now, how they got the big old rocks there? Tricky, but they could do. So, false. Okay, so people say, well, it's just a clock. Who cares? What are these things on the right? Swords. No, but close though, right? They look like swords, and they're in fact stylized like swords. They're comets. So this was an interpretation of the fuzzy, sort of bright thing that they saw in the sky. And in fact, I forget where this is actually from. This picture is not from space. This is an interpretation. These are historical interpretations. So they were seen as omens. So if you could predict, for example, the appearance of a comet, then perhaps you would time your siege of the, enemy at this, because that would be a good omen. Or maybe you would decide, oh, these people need to die, chop their heads off and toss their bodies down this pyramid because I saw one of these, scary, keep it away, right? So in fact, stars were believed to be representations of gods and spirits, perhaps not surprising, right? If you want to give meaning to all of this weird stuff that you see in your day-to-day life, this certainly feels like a potential explanation. The sun is the thing that gives all life on Earth. All of it gets energy from the sun. Well, why wouldn't you think of it as a god? They're responsible for maybe rains, droughts, definitely tides. Changing tides are connected with the moon. So if you want to go and you harvest the best oysters, you wait until the tides are less terrible, you go down and you eat, you come back and you know that the moon leads the tides. And we talked about the omen. We got a little bit of time. Okay, we're going to talk about ancient astronomy. So, about 3,500 years ago. Now remember, you have to chalk on another 2,000 years. So this is about 5,500 years ago. That's not recent. Okay, this is the first time that they developed cuneiform writing, a form of stylized writing that survives. They very well could have been writing on paper, but we don't think so. We don't have any evidence, archaeological evidence, that humans were able to write before this, but maybe they were. And if you've ever cursed at 360 seconds or 360 seconds, 3,600 seconds in an hour, and then like, why wouldn't you just use 10? 10 makes more sense. That's their fault. Okay, they decided that they wanted to subdivide a circle to 360. I don't know why. Can't ask them. Okay.
Why did we follow them?
Why do we follow? Hey, tradition. This is 5,000 years of marking positions on the sky. Okay. So look at this. The Babylonian observation of Halley's Comet in 164 BC. That's only 2,000 years ago. So they did this for like 3,000 years. And you think that just because we came along 5,000 years later, we're suddenly going to switch it up? Yeah. We can't even get the US to be on imperial, or sorry, on metric system. Right? What's a foot? That's a foot. What's a meter? I don't know. Anything else? I'll use any other form of measurement. 2 dishwashers. Okay. So of course, Indian astronomers at this time, Indian from India, not incorrectly named India, in the Indus Valley also predict the motion of the sun and the moon about 5,500 years ago. They create the first working model for the motion of the moon and the sun. Be crazy. And then write it down. That's how we know. Okay, 300 BC, so 2,000 years ago, is the first prediction of planetary motion with the sun in the center of the solar system. Okay, so 2,000 years ago, they decided the sun, center of the universe, and we all go around it. And in 500 AD, about 1,500 years ago, it's the first time that some Indian astronomers are able to predict the reappearance of a comet. So they see a comet, they watch it go across the sky, and they're able to predict in such and such number of years, you'll see this comet. And then they die, and they wait, and people come, and they say, oh shit, you're right. Isn't that crazy? They never even knew if they were right. China is amazing. Okay, China has been keeping detailed astronomical records since 600 BC. When I say detailed, I mean detailed. Okay, so they look for what are called guest stars sometimes. So this is the sky map in Chinese. I don't know which version, which language, or I don't speak any of them, so I can't read this. But essentially, they note something called a guest star in, I think, 1054 AD. And a guest star is just like a star that shows up for a little while and then disappears. They're like, huh, weird. Cool. They see this happen all the time, and they're like, I don't know. And we go, modern astronomers, make telescopes. We're like, what did they mean, guest star? And we go and we look in the place that they saw a guest star, and we see this, the Crab Nebula. And this is an exploded supernova. So they watched a supernova, and they detailed its position so well that we could go and look at the remnant. Pretty cool. So the first star catalog was created by a Chinese astronomer in 400 BC. And one thing I really want to put into your mind right now, right? When we talk about all these things, 5,000 years ago, you think of ancient people potentially as different from us. They are identical to us. Their brain capacity is very similar to us. They just don't have the technology. So imagine an intellectually advanced human being hanging out all the time, looking up at the sky and being like, huh, that's cool. They had to develop writing. You didn't have to develop writing. We just taught you. You didn't do any of the hard work. They had to figure all of this stuff out, right? And they're really good at it. Okay. So the Mayan astronomers, they had to do all of the astronomers of the different types had to figure out what the heck a year was. Because originally some people said, well, it's 360 days. And then other people were like, no, it's really 365. And I'm like, man, it's not really quite right. It keeps slipping. Every time that you don't use exactly the right number, you try to subdivide it to this thing called days, it slips. And our current calendar slips. How do we account for slippage in our calendar? Leap year and leap day. So we sometimes tack on an extra day. Sometimes we don't. Okay. So this is a fix to a problem that we created. Of course, the planet doesn't know that we're leaping. Right? It doesn't know about that. And so the Mayan astronomers calculated the solar year, that is how long it takes us to get around, to better precision than ours currently. So if we still use the Mayan calendar, we would have no leap day and leap year. And in fact, people have talked about, well, why don't we just get rid of the Gregorian calendar and just switch to something that fucking makes sense, like not 28 and then 31 and then 30. Like, let's just do the same number. And no one wants to listen. Okay. I've talked to a lot of people about this. No one wants to change it.
Wasn't the Mayan calendar before the Gregorian calendar?
Yes, a lot before. But we have to remember different parts of the world. And we killed all of them. Right? All the people who could explain this to us good.
And burned everything.
We killed them. Right? History colonization in the United States and in Mesoamerica, not good.
No.
So some people talk about the Egyptian pyramids. Okay, some people talk about this as evidence for aliens. Why is this incorrect? Okay, so here we have Egyptian, right? Here we have pyramids. No one questions that these were made by aliens.
They are.
That's right.
Hey.
Okay, so here's the thing. These people that built these monoliths, built these enormous structures, they just had a lot of time, folks. Okay? Just because you can't do it doesn't mean they couldn't do it. And when we look at something that's amazing, right? Like this, it's huge and intricate and complex, and we say, I don't understand it. The answer cannot be aliens. It cannot be aliens. It is the cheapest, most useless answer because it doesn't give you anything.
The Mayan gods were kind of fun.
The Mayan gods were kind of weird though. Okay, but that's fine. Humans are imaginative, right? You look at something like dragons. Where did dragons come from? Because keep in mind, they did not find dinosaur bones until the late 1800s. So where did dragons come from? What? No, false. Okay, so hold on. Let me finish this thought really quick. So stone circles in Egypt date back to 5000 BC. Again, that's 7,000 years ago. The first time that we saw similar things to what Stonehenge is, which is basically a clock. They say, well, these are perfectly aligned with the cardinal directions, and look, that's not hard to do. We know which way is north. They knew for 2,000 years, they knew everything about astronomy. For 2,000 years. You tell me they didn't think about how to move a rock? Okay. And this idea that it's been there's like some ways to connect the stars, that's not necessarily accurate. Okay. Dog days of summer. Well, you don't really know what that means. Are there any dog days of summer? We say this in baseball. What's that? I don't know what that is. I don't know what that is. Oh, it's a book. Literature. Okay, this comes from tracking Sirius. So dog days of summer were an indication. This is actually an ancient phrase. And this comes from tracking Sirius rising in the east. And when they could see Sirius rising in the east, they knew that the Nile would begin to flood. So the dog days of summer indicated, okay, it's time to fuck out the Nile. That's when, if you knew when the Nile was going to flood, you would save hundreds of lives. Because the Nile flooded rather quickly. If you're living by the Nile, sorry, you didn't. You're not living by the Nile. Okay, any questions before we finish? So tomorrow we're gonna have a lab. It'll start at 6 unless you look up and it's fully clouded, or you get an email from me saying it's too windy. Because there is a slight wind advisory right now. Yeah. The observatory. You guys know how to get the observatory? Oh yeah, so you drive up to the observatory. Okay, interesting.
If you would literally like throw an observatory on Google Maps, it takes you up there.
Yeah, there you go.
Do not walk up.
Yes, yeah, absolutely.
What end? Stop sign, you go.